Good morning, my dear students. Today we are going to discuss about computers applications in fermentation technology. At the end of the class, you will be able to know usage of computers in fermentation technology and what are the different ways of controlling the process by using these computers. So different types we will discuss. Coming to the computer applications, we know that nowadays almost all industries are using computers for controlling their processes. The availability of cheaper and small computers has widened the interest in possible application in various fields of bioprocess industries. Because of availability of small computers, these are nowadays used in pilot plants, research laboratory, and even small scale industries also. The reason is the financial investment required for the purchase of this online computer is very less compared to the relative to the entire process or systems. That's why it is used widely everywhere. So there are three distinct areas of computer control, or you can call it as different functions of a computer control. The first one is logging of process data, and second one is data analysis, which is also called as reduction of the logged data, and third one is process control. Okay, there are three functions of a computer control in a fermentation process. So out of these three, the first one, that is called as logging of process data. The simplest task for computer is logging of the data. We know that we use different sensors for measuring the different variables in a process industry. In a fermenter, for example, we measure temperature, we measure pH, we measure concentration, we measure dissolved oxygen. So for that we use different sensors. So all these sensors continuously measures the value and they will send that signal to the computer. Then these values will be entered into a computer. So that process we call it as logged. Programs have been developed so that by the reference to the real-time clock, the signals from the appropriate signals will be scanned sequentially in a predetermined manner and logged into the data store. For example, we are measuring this value. It's a continuous process. So signals coming from these values will be displayed on the computer for each 2 to 60 second intervals. Okay. So this we call as preliminary scanning. All variables will be scanned for the given predetermined time intervals. Okay, which is generally less than 1 minute. Okay, and this data will be displayed on the display unit. Okay, so if any of this data deviates from the required set points, okay, then printout it will activate the printout, or if these values goes to any extreme extreme side, then alarm may be activated. Okay, after this preliminary cycle, it's a continuous process. Okay, a final cycle of sequence, it will be between 5 to 60 minutes. Okay, for each 5 to 60 minutes, the program instructs that sensor readings are permanently recorded on a printout or in a data store. Okay, so preliminary scan data are only available for display unit. If any error is there, then only this will be stored. Okay, action will be taken based on that. Otherwise, this will be removed from the storage. But each 5 minutes or 60 minutes, in between 5 to 60 minutes, it will vary from process to process. Whatever it is instructed, it will do, and that data will be stored for future analysis. Okay, at the same time, as the online data is being recorded from the sensors, okay, analytical data for parameters such as viscosity, microbial growth, substrate utilization, and product transformation, these values will be measured separately. Okay, online cannot be measured, so offline will measure all these values, and these values also will be logged into the data stores for specific known times. Okay, thus now it is possible to record data continuously for a different range of parameters. Okay, from different sensors. Okay, see here, not only that, in computer control you can control the more than one system by using a single controller, so a single computer. So this computer can accept data from different units, fermenter 2, fermenter 3, or distillation column. So for that data also, for controlling those equipment also, data can be monitored or controlled from the same computer. Okay, that is the advantage of this computer control. Okay, so in this way, this data logging will take place. So in data logging, we'll have only data entering. Okay, so we are getting the information from various sensors that will be recorded. Okay, based on that values, we'll take the further action. Okay, once the data recording or data logging is completed, the next process is data analysis. Okay, it is also called as reduction of logged data, because we may have a very high amount of data, large data we can get, but that can be converted into small data, required data, whatever it is required, that only will take. Okay, for this conversion we use various computer programs. Okay, or this data reduction can be done by data analysis system, which will have mathematical equation. We know that entire table you may have x values, y value, that can be simply written in terms of mathematical equation, modeling equation. Okay, so easily we can remember that data, and action also can be taken easily based on that model. Okay, in that way this data reduction will be taken place. Okay, see, the analysis information can be put on a printout, or it can be fed into a data bank, or utilized for process control. So because computer can undertake so many calculations very rapidly, it is possible to design programs to analyze fermentation data in a number of ways. Okay, for analysis you can use linked mainframe computer. Okay, or you can go for dedicated small computer. Any of these things you can use. For example, data analysis, RQ value, respiratory quotient of a culture, can be calculated from the outlet gas flow rates. Okay, if you can able to measure how much amount of gas is flowing outside, like oxygen or carbon dioxide, okay, you can know the RQ value. Okay, similarly from this flow rates you can also calculate how much amount of reactants are converted into products. That means product formation you can know. Okay, unconverted amounts you can know. If you know the elemental balance and compute stoichiometric equation, you can also do the all mass balance equation necessary for the process. Okay, so all these things, okay, including yield, okay, you can calculate by using this data analysis part. That's why it is very, very important. Okay, once data logging and data analysis is over, then the main process is process control. Okay, process control is performed using a computer program. Signal coming from the computer are fed to the pumps, valves, switches via the interface. In addition to the computer program, the computer program may also contain instruction to display the devices or indicate the alarms, etc., activate the alarms, etc. Okay, all these things will be taken care of by the computer control system. Okay, so in this computer control, there are three levels. Okay, three levels of process control. Okay, the first level is very simplest one. As the level increases, complexity also will increase. Okay, so it will have very complex programs, and they need greater overall understanding of the process. The first level, which is very simple. So first level includes all routinely performed activities in the industries, such as manipulating valves, opening, closing, or starting of the pumps, or closing of the pumps, or calibration of the instruments, online maintenance of the instruments, okay, and shutdown procedures. All this comes under first level. Okay, sterilization, okay, this also comes under first level of operation. Whereas second level of process control involves little bit complex problems, like parameter controls like pH control, temperature control, foam control. Okay, so these all have to be controlled with the help of direct digital control. Here we have two methods of controlling. Okay, one is called as direct digital control. This we use in second level. Third level will go for set point control. Okay, so that we'll discuss later. Okay, so in direct digital control, the computer program determines the set point values and the control algorithms such as PID, These are all are part of the computer program. Okay, so better control is possible as the control algorithms are mathematically stored functions rather than electrical functions. This procedure allows for greater flexibility and more precise representation of the process control. The system is not expensive. Because we don't need any separate controllers. Okay, only one single computer can control the entire system. So it is very easy. At the same, but the problem is, disadvantage is, if a computer fails, okay, then we cannot control the process. Okay, there should be some manual backup facility. Otherwise, we cannot get the accurate control over the system. Okay, this is second level. Okay, now coming to the third level, this is very complex process. Okay, see here, all the control functions are performed by an electronic control. Okay, that we'll discuss later. Okay, so here we'll have linked computer as well as electronic computers. Linked computer only logs the data from the sensors. Whatever data is received, data will be entered from the computer. Similarly, set points will be instructed to the electronic controls by the main computer. Okay, see here, all controlling operations will be done by electronic control. Okay, this computer, whatever you are taking, that will act as a supervisor. Okay, it will instruct the electronic controller to do the control. That's why this type of control is called as supervisory set point control or digital set point control. So when this is also called as SSC or DSC. When SSC is used, the modes of the controller are limited to proportional, integral and derivative. Okay, the advantage of this method is even if computer fails, okay, the entire entire process will be taken care by electronic controller. So here we'll have very good accuracy. Okay, so these are the three levels we will have. Okay, here we have discussed about two important types of controllers. One is direct digital control. So here the fermenter is directly under the control of the computer software. Okay, that is DDC. Okay, whereas supervisory set point control SSC, it involves the here the fermenter is under the control of electronic controllers, whereas electronic controller will be supervised by the computer. Okay, that's why it is called as supervisory set point control. Okay, these two systems we have discussed. Okay, now with the help of diagram, we see how these two will work. Okay, so DDC as well as SSC both will discuss with the help of an example. Okay. Okay, for example, here we have used a fermenter. Okay, so here we want to control pH by using alkali or acid. Just assume. Okay, so for controlling this process, here also we use ordinary feedback controller also only. So the mechanism will be similar. Okay, so traditional feedback control mechanism we use here. So here we place a sensor. So sensor is directly placed at the control variable, so it will measure that value. So it is pH electrode, so it will give signal in the form of electrical signal. Okay, this pH meter we are using, that value will be sent to a controller, computer controller, where computer control will check this value with the set point value. If it detects any error, based on the error, it will take the compensatory action. Okay, it will either on the acid or alkali addition, whatever it is. Okay, as per the requirement it will do. See here, we are measuring by using this pH sensor. It is giving values in the form of electrical signals. So these are called as analog signal. Okay, see, this electrical signal cannot be understood by this computer, because computer can know only digital language. This language it cannot understand, voltage, current, this it cannot understand. So we need to use transducer. Transducer is nothing but an instrument which converts signal from one form to another form. So here we are using transducer of type analog to digital converter. This is called as ADC, analog to digital converter. So it will convert this electrical signal into digital signal that will goes to the computer through this interface. Then computer will compare that value with the required set point. So if it detects any error, then it will take the action. Okay, so it will send that signal again back to the control valve. So it will send that signal through the interface. But again, this computer can understand only digital signal. It can accept digital signal. It can give only digital signal. So what happens is, this digital signal will get that again we have to convert into analog signal, because these equipments whatever we are using, they cannot understand digital language. So again we have to reconvert that into its initial form. So we have to use digital to analog converter. This will convert digital signal into analog signal. Okay, so some electricity or pressure, if it is a pneumatic controller, pressure it will be converted into pressure. Okay, so like that. Okay, so signal is now converted. Now according to the signal, this pump will open. Okay, or it will start, valve will open or pump will start. So when pump start, here we have acid or alkali as per the requirement. Okay, this acid will enter into the process. Okay, so addition, as we already discussed, we will have two types of things for a pH control. Acid cycle will be there, then followed by mixing cycle. So acid control cycle will last for 0 to 60 seconds. Okay, so after addition we'll go for mixing cycle. Mixing cycle will last for 5 to 60 minutes. Okay, sorry, 0 to 5 seconds is addition cycle, and 0 to 60 seconds for mixing cycle. Okay, after mixing cycle, again it will measure the value and again try to compare the value. Based on that, again it will give the signal. So this is how it will come out. This is just like ordinary feedback mechanism only, but in feedback mechanism here we have used controller. So controllers are directly accepting the values. PID controller, for example, it takes the signal directly. But here we are using computer, so we have to use this transducer, ADC and DAC, analog to digital converter or digital to analog converter. We have to use extra. This computer can be linked to a mainframe computer. Okay, so similarly it has provision to get printouts, okay, or visible display unit, that is nothing but monitor. Okay, you can store the data, or you can use tele information, or you can use graphic information. Okay, it also will have timer as well as alarms. Okay, if a value deviates from the required value, alarm will be activated. So this is how this computer will control the entire process. So this is called as direct digital control, DDC, first level. Okay, second level. Okay, so once this DDC is over, okay, we can go for this SSC. SSC is called as supervisory set point control system. Okay, so here this example we have temperature control, pH control, dissolved oxygen control. All these three are simultaneously shown in this example. Okay, see, we know that all control functions in a SSC are performed by the intelligent process control, that is electronic controllers, and the computer only communicates with electronic control in order to log the data and send new set points when instructed by the designer or user. Okay, so this is how this will work. So here also mechanism is similar. Okay, so this is our fermenter. We want to control temperature, pH and dissolved oxygen. So this is dissolved oxygen probe, and second one is this is pH probe, and this is temperature probe. For example, temperature we want to control. So we are measuring temperature with the help of sensor, that is thermocouple. Okay, thermocouple will have signals in millivolts. Okay, very low signals it will have. So to what we do is, to get accuracy, we'll convert that signal into, we'll amplify the signal into bigger signal. Okay, for that we'll use amplifier. Then it will goes to the controller. Then controller will compare that with the actual value. Based on that, it can take the action. For example, temperature we are controlling. So here it will based on the measured value, this computer electronic controller will signal to this relay. Relay is nothing but a switch. So it will activate the switch so that more amount of electricity may enter, so that more heating may take place, or otherwise it can reduce the voltage that will enter into the heater. In that way it can reduce the temperature inside the tank. In that way it will control. Okay, everything is same. Here in previous DDC, here in place of this multi-loop process control, electronic controller, we have computer, but here we have electronic computer. Okay, this electronic controller is connected to a supervisory computer. So all the data will be entered from this computer only. All the set points will be given set by the this computer only. That's why this computer will act as a supervisor. That is why it is called a supervisory computer. So in this way we control the process in this type of controllers. Okay. So in computer control we have discussed about the applications of computers. Okay, the reasons for wide usage of computers. Then we discussed what are the different stages involved or levels involved in a computer controller. First level is all routine operations will be done. Okay, whereas in second level, important parameters like temperature, pH, these are will be measured with the help of direct digital controller. Okay, sometimes if you need accuracy, okay, then we have to go for set point supervisory set point controller SSC. Okay. Thank you for watching.